This is lecture 5, example 1. This is our first example doing subroutines, and I thought we'd get right into it here. So I told myself, I promised I'd be a good programmer. For all these programs, I would start with a flowchart, and so I'll do that with this one. So what I'm going to do is write a subroutine that, what does it say? It multiplies the number in x10 by the number in x11, stores the result in x15. So the notion is, well, why don't I just use a multiply instruction? Well, the issue is that the instruction set does not have a multiply instruction, and so my job is to figure out how to multiply using what instructions I have in the instruction set. So it happens, multiplication is kind of an abstraction of addition. Essentially, I'm just going to add over and over again, which means add iteratively, which to you means I am going to stick it in a loop and add over and over again. And so the way I'm going to do it is start at 0 and keep adding one of the operands. I forgot the name of it, multiplicand, or I actually don't remember the technical names of it. I'm going to add one of the operands the number of times associated with the other operand. And so what I'm going to do here is use one of those operands to add over and over again, and the other one I'm going to use as the iterative value in a loop. So let's do this thing. So this is my terminal character. The very first thing I want to do in any problem like this, since it is some type of accumulation, is clear accumulator. I'll keep a register as accumulator. Obviously, it's going to be x15, but I'm going to keep technical details out of this. So I'm going to say, initially, after I clear the accumulator, I'm going to check the condition. So I'm modeling this as a while loop, which is, just by my choice, I think it's a better idea. And then I'm going to say, if that value is equal to 0, I'm going to call myself done. Okay, if that value is not equal to 0, I am going to do an add operation. I'll say an accumulate operation, and then come back into this thing. Probably didn't do that really well. No. Good enough. That's my flowchart. Essentially, I'm going to accumulate until that value is equal to 0. And, of course, I forgot something, so let's get rid of that. So accumulate, decrement, value, and then I'll go back to 0. Okay, much better. That's actually going to work this time. So, all right, there's my flowchart. So let's do this in real code. So what I'm going to do is give this a name. This name is just a label. That's a subroutine name. And I always start these out the same way with another label, which is init. Okay, so the init in this thing is going to be a move instruction. Essentially, I'm going to start the answer, which is going to be accumulator. I'm going to start it off at 0. So x15 is where my results is. And so I'm going to move x0 into that. So that looks good. Then the next thing I'm going to do here is I'm going to check it. Check one of the operands anyway. This is a BEQ, and I'm going to say if x, this is arbitrary, x11 equals x10, I'm going to call myself done. Okay, that's it, really. And then I typically will come down here and write a done label because it's doable here. And there's my return. So the return, I'm going to use that right now. It's a pseudo instruction. I use it to return from subroutines. There's a lot going on in a subroutine to make it happen. We're just not there yet. So for us, just use the return and it will work. You don't have to worry about it. We'll talk more about it later. I like using lowercase on these things. I don't know why I started on uppercase. Okay, so there's my branch instruction. If I'm done, if there's nothing left to do, I'm going to go down and make this right. It's not x10. I'm comparing this register to 0 because when it's 0, then I'm done. Okay, we'll try that again. So that matches that right there anyway. Okay, so if this branch does happen, it jumps down here. But if it doesn't happen, I go here and I'm going to accumulate. And so the accumulate is going to be an add instruction. And I'm going to add x15 to x15 and to what I'm going to do here is add x10. Oops, and I ran out of space on this. Need a little bit more space there. x10. So what it's doing here is I'm accumulating x10 over and over again. I'm accumulating that in register x15. So the key to making this work is putting another add instruction in there. Add, this is going to be add immediate x11. God darn it. Gonna get this messy. That's the thing about doing it live. Add immediate x11 x11 minus 1. Okay, so this is add immediate. This is adding 3 registers. This is taking the value in x11, subtracting 1, and storing that value in x11. So this is one of the operands. So what I'm doing in this thing is adding x10, x11 number of times. So the key to making this work now is to jump back to this instruction here, which I don't have a label for it, but I'll come back and add one. It looks good. So essentially, after I do this decrement here, I'm going to jump back and check the condition, which means I'm jumping back to the instruction associated with the loop label, which is this branch if equal instruction right here. So this is going to, once again, this is going to go through this loop x11 number of times, execute the body of that loop x11 number of times. The body of the loop is this add instruction right here. So this is the complete body of the loop, is just this one instruction. These are technically speaking, I think these are administrative instructions right here. They don't really do anything except, jump around. The meat of the whole problem is this add instruction right here. So this is, once again, this is implementation of an add algorithm, of a multiplication algorithm that is essentially repeated addition. And I'm going to think, I know the solution's sitting after this. Yeah, I did call the name a little bit different, but the more important thing is that I can change these values around and make it an equivalent problem. This problem right here, it adds x10, x11 number of times. I could have added x11, x10 number of times. So essentially the way I'm going to do that is by essentially swapping the values of x10 and x11. Okay, so convince yourself that's just going to come up with the same answer as the previous problem, and we'll call this done.